My name is Thomas Yen, and I'm the CEO of Tensor Tech. And our company focuses on space. Today I'm going to introduce you about our product and also how we are going to tackle this market. So every satellite in space, they need to control its orientation along X, Y, and Z axis. So in order to control each axis orientation, they need one motors. So totally they will need 3 motors in a spacecraft. So like in the picture on the left side, you can see in each black box there's water spinning in clockwise or counterclockwise. But we found this kind of design was too many weight and also the volume on the satellite. So we come up with the design to use a spherical motor to solve these problems. This spherical motor has a rotor inside, and this rotor is a sphere. This sphere can rotate in X, Y, and Z axis. So it can achieve 1/3 of the weight, volume, and power consumptions compared to the traditional design. So, however, every satellite in the space needed to use this kind of design. So this is a large market. Help me to. So compared to other competitors in this market, our device can also achieve another benefit. That is the lead time. Because traditionally, you need to collaborate other many motors in the whole satellite. So it will take a lead time up to half a year to a year. So our design is a simple one. So we can only calibrate on this single axis, and then it can achieve the control in X, Y, and Z directions. So it leads us to a shorter lead time compared to our competitors, which is only 4 weeks. That we do. So, in the first stage, we are going to, our market is targeted on the nano satellite, which is the type of satellite that weighs less than 10 kilograms. And then our next stage is to go to the small satellite market, which is the satellite that weighs less than 1,000 kilograms. Our final goal is to build an integrated platform for our customers so that they can just put on their payloads and then they can launch their satellite into space. So right now for our company, we have already finished several environmental testing, including the vibration, thermal vacuum test, and also radiation test. So next year we are going to launch 2 of our first satellites to space and then verify our performance in the space environment. So in 2022 we are going to officially get into this market and then target our first customers as for the research institute customers. And then later on in 2023, after this research institute has published several papers which are going to be our advertisements, and then we are going to tackle our commercial customers, which are companies who are building satellites and launch them to space in order to access data and sell those data. So our company has focused on this spherical motor technology for more than 4 years. Originally it was just a research, but then we found this opportunity in our lab back to NCKU, that we have the National Space Organization to build a single-axis motor for their satellites. But then we found out this spherical motor has very many benefits on those satellites. So then we start this company and then try to push this product not only just a research, but could be a product that can make some changes to this market. So this is our team, and 4 of us, we are all classmates since high school, and then now we have cooperated with each other for so many years, and we have a dream that we wanted to make space accessible for everybody. And this is the key, is to how to make this market as a commercial one. And so right now many companies are tackling this problem, such as SpaceX, they are using recycling the rockets in order to lower down the cost. But also another key for satellite builders is that how to shrink the size of satellite. So there's one last obstacle for this challenge is that how we can shrink all these component size. Like for example, the control board and also communication system, they can already be shrunk into a very compatible size. But for the energy control system, such as motors, and they have some limitation in terms of their power densities. So we hope to solve this problem by using spherical motor, because you can directly have 30% of the weight, volume, and power consumptions compared to the traditional architectures. So that's what Tensor Tech wanted to achieve with this spherical motor. Thank you very much for your attention today. Thank you.